This is section P.6. We are factoring, and this is day 1. So, need to talk about the steps to take when we are factoring polynomials. And the first thing we need to do is make sure that the polynomial is written in descending order with respect to the exponents on the variable. And if there are multiple variables go by alphabetical order. So let's look at what that means. Let me get my pen here. If we have x plus x squared, if we were to write that in order, that would be the x squared first and then the x. You are going by the exponents only. If I have x y squared plus x squared y, what I mean by alphabetical order is I want x to be my dominant variable. So we have x squared is the larger exponent, and I'm going to write that first. So in order would be x squared y, and then plus the xy squared. And that would be in descending order. The next thing you want to do is factor out the greatest common factor, if there is one. And just so you know, this is what we have as much as possible that is in common between all the terms. And finally, to actually factor the polynomial with the certain processes that we will learn, it depends on how many terms we have in the polynomial. When we have 2 terms, the possibilities are that you may only be able to factor out a greatest common factor, and then that's it. But we always want to look to see if we have one of the next 3 possible special factoring formulas. And the special factoring formulas are the difference of 2 squares, and if we have some expression, it's not just x and y, these are just variables showing any possible value. So any value squared minus any other value squared, then that's a difference of 2 squares. And the factoring for that is x plus y and x minus y. If you have the difference of 2 cubes, this should be x to the third right there. Let me correct this in red here, I guess. I'll do it in blue. So this would be x to the third there minus y to the third. So any value to the third power minus any other value to the third power, then your factors would be x minus y times x squared plus x times y plus y squared. And then if you have the sum of 2 cubes, then you would have x cubed, x to the third, plus x plus y to the third. So any value to the third power plus another value to the third power. And the factoring for that would be x plus y times x squared minus x times y plus y squared. So the thing about these two is your first factor here with the single exponential values, the exponential values that are 1, they match. The operation matches what you see in your original expression. And then when you get to the second polynomial, the trinomial part, the first operation is the opposite of what you started with. So here I started with minus, I go to plus. In this one I started with plus, I go to minus. Other than that, everything is the same exact format between the two. Now if I have 3 terms, I am looking at the possibility of being able to factor this trinomial using what is called the product sum rule. and we'll be covering that process in today's notes. The two terms, the special factoring formulas, we will be covering in day 2. Okay? And if there are 4 terms, we would do a process called factor by grouping, which is also going to be covered in day 2. Okay, but we need to know that there are different types of factoring for depending on how many terms you have in the polynomial. All right, so let's look at some examples. If I have 12m squared minus 20m, I have to realize, okay, this is 2 terms. It is written in descending order, and I need to factor out a greatest common factor. If I look at this, I have 12 and 20. The greatest common factor between 12 and 20 is 4. When I look at the variables, the greatest common factor is always the smallest exponential term variable between the two. So I have a common m. When I factor that out, I am dividing the original term divided by the greatest common factor. So 12 divided by 4 is 3. M squared divided by m, you're taking 1 away from the exponent. So I have 3m minus 20 divided by 4 is 5. M is already being taken out. That leaves me no m's, and I am done. 4m times 3m minus 5. Let me do that over. Okay. The second example, z plus 2 squared minus 5 times z plus 2. What we need to be able to understand here is that we've got a common expression between these two terms. And it's kind of like having a common variable. We take the smallest exponential value of the two terms, which is z plus 2. So we take z plus 2, and we're going to factor that out. So I'm going to write that out in front of whatever I have left once I factor it out. So if I have z plus 2 and I factor out one of these z plus 2's, I'm taking away 1 from the exponent. So I will have z plus 2 left. Think about it. If I multiply z plus 2 times z plus 2, I get z plus 2 squared, right? So that's exactly what I should have right here. When I factor out z plus 2 from the second term, this is going to be gone, and I'm left with just minus 5. Now I'm done with the factoring, but if you look here, I can simplify this a little bit. I've got z plus 2 minus 5. So that's going to end up with z plus 2, and positive 2 minus 5 is negative 3. So I'm going to have z minus 3. And those are my factors for this example. All right, here is the product sum rule. The product sum rule is something we are going to use when we have a trinomial. If we have a trinomial where a is 1, where the front value is empty and it's a 1, and all we see is the variable squared, the product is just the c value, and the sum is the b value. Now, if c is a positive number, meaning this is a plus right here, so if c is a positive number, c is greater than 0, then the factors of the c will add to get the b. If c is less than 0, if we have a minus here in our trinomial, then the factors of c will subtract to get your b value. Okay, so let's look at what we have here. We have a trinomial here. If we follow our steps that I had on the first page, first of all, we want to put this in descending order. So I want the t squared written first, so that's going to be negative t squared, then the minus 5t, and then we've got positive 24, so plus 24. Now, you might think that there's not a greatest common factor here, but since the t squared is negative, we want to factor out the negative 1. And when we factor out the negative 1, we're going to get t squared. Negative 5 divided by negative 1 is positive 5t. 24 divided by negative 1 is negative 24. Now we're going to factor this using the product sum rule. My product is negative 24. My sum is 5. Okay, since this is negative, we are going to subtract the factors of 24 to equal 5. The factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. I have to look at these pairs of factors and look to see which ones can I subtract to get 5. And I need a positive 5. So if I take 3 and 8, and I have 8 minus 3, that gives me 5. That means I have a positive 8 and a negative 3. So what I'm going to do is I'm going to create two sets of parentheses, put my negative 1 out front, and t squared is created by multiplying t by t. So each factor is going to, each set of parentheses here is going to have a t to start. And then to fill in the rest of this, I put my positive 8 and my negative 3. So plus 8 and minus 3. And those are my factors for that trinomial, t plus 3 and t minus 3. And then with the negative 1 for my original trinomial. This example, it's already written in descending order. There are no greatest common factor other than 1, so nothing need to do there. So my product is the 48, and it's positive, which means when we have the sum that is negative 14, we are going to add the factors to get negative 14. So our factors of 48 are 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. Which pair of numbers am I going to be able to add to get 14? Well, 14, I get 6 plus 8, but I actually need negative 14. And to get negative 14, I need negative 6 and negative 8. Well, negative 6 times negative 8 is still positive 48, and negative 6 plus negative 8 is my negative 14. So that's exactly what I need, negative 6 and negative 8. So when I go over here, I set up my parentheses. I have x squared, so I know I'm just going to have x and x for x times x to get x squared. I'm going to fill in the rest of my parentheses with these two factors that I got, negative 6 and negative 8. And those are my factors for that trinomial. This example, at first, I look like, oh, I've got a number there. And I might need to follow the factoring rule that is set down here where a is greater than 1. However, if I follow the processes that I stated in the first page of notes, I need to write it in order, which it is, but I also need to look to see if I have a greatest common factor. If I look at 3, 6, and 45, they can all be divided by 3. So I do have a greatest common factor of 3. So if I take 3 and I factor that out, I'm going to have x squared. Negative 6 divided by 3 is negative 2. The x is just going to stay with it. And negative 45 divided by 3 is negative 15. Now I can see that this trinomial is just the same as the other two I've already done. So my product of negative 15, my sum, I'm just going to put P and S, is negative 2. I need to subtract my factors to equal negative 2. My factors of 15 are 1 times 15 and 3 times 5. If I'm subtracting these, I'm going to have 3 minus 5. 3 minus 5 is negative 2. So that means I have a positive 3 and a negative 5. Okay, so when I set this up, I have my 3 out front. I'm going to set up my parentheses here. Again, I have x squared, so I'm going to have my x times x. So I need to put x in each factor here. Then I'm going to complete these with my positive 3 and my negative 5, so I get x plus 5 and x plus 3 and x minus 5. And those are my factors. Now let's look at factoring a trinomial when we actually do have a greater than 1 and we cannot factor it out. So when we have a trinomial written in the proper format, the product is going to be that number out in front times the last number. So A times C. The sum is still the B. So in this example, I have 6 and I need to multiply it by negative 10. That's negative 60. So my product is negative 60. My sum is positive 11. Because it's negative, I need to subtract to equal negative 11. My factors of 60 are 1 times 60, 2 times 30, 3 times 20, 4 times 15, and actually I could stop there, even though I could go on to 5 times 12 and 6 times 10. Okay, because I have to subtract. Oh, yeah, subtract to get negative 11. And if I do 15 minus 4, that's 11. But I need, positive 11. So I do need positive 11. So 15 minus 4. That means I have a positive 15 and a negative 4. Now, because my product was created by multiplying these two numbers from the trinomial, my numbers here are also created by the factors of those numbers. So if I come up with the factors of 6, 1 times 6 and 2 times 3, and I'm going to go ahead and put x in there with it, 1x and 6x, 2x and 3x. My factors of 10 are 1 times 10, 2 times 5, and that's it. I need to look at how am I going to pair up one of these pairs of factors with one of the pairs of factors over on the right to get 15 and 4. If I look through here, I have 2x times 2, or 2 times 2 is 4, and 3 times 5 is 15. Okay, so that works. So if I take and pair up the 2x with the 2, that gives me my 4. And if I pair up the 3x with the 5, that gives me 15. So when I set my parentheses up, I need to consider that. My 2x and 3x are going to be in the front of each set of parentheses. Oops. That would be 3x. Okay, and as far as pairing them up, you always pair out, like think of your FOIL method. You have outer and inner. So my 2x is going to be the outer because that was the first, and now I need to go with the last. So 2x is matching up with 2, so I need the 2 there. The 3x is matching up with the 5, and that's going to fill in this inner here, so I need the 5 there. I need negative 4. When I had these factors, I had negative 4. Well, the 4 comes from the 2 and the 2, so I need a negative over here for the negative 2 to make that negative 2 to be multiplied by positive 2 to get negative 4. And 15 is positive, so I'm going to have that to be positive. So here are my factors for that trinomial. So it gets a little bit tricky, once you do the product and sum and you get your factors. But once you do this a couple times, it goes pretty quick. And that's it for day 1.